And now we're going to switch artwork here, different theme, different motif here, different fonts. And clearly we're talking about a different project now. So I'm going to talk about the Crossplane project now, which I am a founder and a maintainer on that project as well. We open sourced Crossplane on December 4th of last year. And I remember that date really, really well because I stayed up all night to finish up writing the documentation and fixing last minute bugs before we went live with the articles we had already given to the press to publish December 4th. So nothing like the motivation of an impending deadline. So what is Crossplane? So we talked about Rook, let's talk about Crossplane. And so it's important to note that this is also an open source project inside the Kubernetes ecosystem. It's compatible with OpenShift as well. It runs in Kubernetes and any Kubernetes cluster. But to think about Crossplane, it's the way to think about it is a multi-cloud control plane. So Kubernetes can be thought of as a control plane for a cluster of figuring out where to run the pods or where to how to set up services and load balancers and ingress and all this sort of stuff for one cluster. Kubernetes is a control plane for one cluster, and so you can think of Crossplane as sort of a natural extension of that, of a control plane for many clusters, for many clouds even. It doesn't even need to be clusters. So we can start thinking about how do we run our applications across cloud providers, across different regions, across on-premises environments. How can we start making our applications run in all those places in a portable way? And so this is not a massive experience departure from Kubernetes. This is, there was a lot of smart people that worked on Kubernetes, and there's a lot of lessons that came out of writing a solid container orchestrator, in Kubernetes. So it uses the same declarative management style API that you see in Kubernetes. You can create, YAML files to declare your resources, use kube control, things like that. Crossplane's a set of smart controllers or operators, if you will, similar to Rook. And what they do, those operators, instead of managing storage systems inside of Kubernetes, they manage the life cycles of all sorts of services and infrastructure, like Amazon's RDS or Google's Cloud SQL or Azure's Kubernetes service. All these interesting types of resources we can start scheduling and provisioning and doing so with this multi-cloud control plane. It also has a scheduler aspect of it too, so you can start thinking about where's the best place for this application to run. Should it run in Google? Should it run in Amazon? Should it run in a mix? You could start making smart decisions about that. And it's open source, community driven as well, just like Rook is. We kind of talked through this a little bit already of why you would even want to do multi-cloud, and that's kind of the power of portability is the power of choice. So we can start making decisions about what features are important to us in the cloud providers. Where do we want to run geographically? What's the cheapest? Cost arbitrage, all that sort of stuff. And we talked about the declarative API as well. So we believe, as the Crossplane project, we believe that there's a convergence on the Kubernetes API. That's a good way to manage our software, manage our applications, manage our resources. So just like any other Kubernetes application, you can use kube control to work with it. To specify configuration or create resources, et cetera. There's this whole ecosystem that's built around Kubernetes tools and the Kubernetes API. There's all sorts of tools, like Compose and Helm and all these different tools that make running in Kubernetes easier. And so we can take advantage of those. So these custom resources that the Crossplane declares, what they are is they manage cloud provider services and the infrastructure in cloud providers. We have our custom controllers to configure them, deploy them, fail them over, all sorts of automated tasks to set up and run our cloud provider managed services easily. And just like the Rook project, it's sitting in a control loop where it's running an active reconciliation where external changes happen or the user declares a new desired state that they want, and those controllers will sit there and make sure that what you want to happen, what the user wants to happen, is always what ends up in the cluster. So let's talk about the architecture here. This is a little bit prettier graph here than the Rook architecture was. But let's work left to right again. So on the left side, we have various ways that you can interact with the Crossplane control plane. So you can use CLI and tools, which would be like kube control. You can use client libraries like client Go if you want to write Go code. You can talk to it that way. Dashboards, user interfaces can be built on it. The important thing here is that in the middle here, it's all built on the Kubernetes API machinery again, right? The Kubernetes API server and etcd for persistent storage, and then a set of resource controllers and custom resources, a scheduler. All that stuff just needs to be built on the Kubernetes API machinery because it's so extensible. You can just run arbitrary software on Kubernetes API and build new solutions like this. So on the right side of the graph, we have the big three cloud providers in the United States at least, and all the services that they have, database services, AI and ML, serverless stuff, managed Kubernetes. The Crossplane control plane can configure and manage and interact with all of those things. And then in addition to the major public cloud provider players, there's a number of independent cloud offerings that are interesting as well. There's a lot of hoopla in the ecosystem right now. I think that came out yesterday or so of the news that Amazon's doing their own Elasticsearch, their fork now they're going to maintain, and independent open source projects like CockroachDB, Mongo, Redis, right? Some of them are even changing their licenses because they are not getting a fair deal from, in people's opinions, they're not getting a fair deal from the major cloud providers, and so they have interesting, services to run as well. The runners or the founders of those open source projects, they're the experts on those. They know how to run the best Elasticsearch or the best Redis cluster or MongoDB. They have value-added features in there, enterprise offerings, et cetera, that offer the best of breed, really, to run some of those projects. But the point is here that the the Crossplane control plane can control all sorts of those services and provision them for you and get them ready for you for your application to consume. So here's where this gets interesting to me. So yes, we can control all those specific cloud provider services, et cetera, but that's only part of the story, really. It gets interesting for me here when we start thinking about those abstractions. Remember we were talking about pods and volumes in Kubernetes. We can do the same thing for message queues, databases, object storage. All these interesting types of services can be abstracted, and our applications can declare a dependency on the generalized abstract concept of a database, like MySQL or Postgres. And so very similar to what Kubernetes did for volumes, like a volume can be from EBS, it could be from Google Persistent Disk, it could be from Rook, Ceph, right? Kubernetes did that abstraction so your pod doesn't have to know about that. It just knows that it's talking to a volume. It doesn't matter where it came from. Very similar to that, your application through Crossplane can now just say, I need Postgres. Give me Postgres. And our Amazon RDS or Google Cloud SQL will be brought up to fulfill that need for Postgres. And so this gets to that mantra of write once, run anywhere, where you write your application YAML one time, you say, I need Postgres, I need object storage, make it happen, and then you can run that Google, Amazon, whatever, without changing your application at all. So portability is becoming more accessible now with this Crossplane project. A big tenet here too is about a separation of concerns, where a developer, an application developer, an application author they talk about their application, their workload, and they don't need to know the details, the environment specifics, the policies, constraints. They don't need to know that configuration. The administrator will define all that for them. And this is exactly like what you see with storage classes, where a pod, the developer who's declaring a pod for their application, they just say they use a storage class, right? They don't need to know the details about where that storage is coming from, if it's coming from Ceph or EBS. That's a separation of concerns. The administrator can worry about the specifics and the environmental details, and the application author can just worry about their application and its general needs. And so this opens up dynamic provisioning for all these new types of resources. The scheduler, the scheduler here I think is one of the most powerful parts about this design, where it's one thing to say, yeah, I can run my app in Amazon, I can run it in Google, I can run it in Azure or Alibaba, whatever. I can run that in any of them without changing my app. That's cool, but it gets much more powerful when you have a smart scheduler that makes those decisions for you. Let's say you can declare some sort of policy like, oh, I want to always use the cheapest cloud, no matter what it is, or I always want to use the cloud with the highest reliability, or whatever policy you want to specify. The scheduler can take that into account when it's figuring out where to run your application, which cloud to run your application in. It can make decisions about scheduling your workload to a geographic location around the globe that's closer to where your users are going to be. And this is similar to the Kubernetes scheduler, where you can specify some policies or some affinity, tolerations, taints, and all that sort of stuff. So the Kubernetes scheduler takes into account which node to put your pod on. But this is much bigger, where the Crossplane scheduler will be able to take into account where in the world to schedule your application. All right, so it is demo time, and I'm going to use the same Minikube, and I believe it's running. Yep, okay, good. So we have a Kubernetes cluster up, and let me go ahead and install Crossplane real quick. I should have done this earlier. I'm just going to, there we go. I'm going to install Crossplane onto this Kubernetes cluster. And then we are going to, what we're going to be focusing on here is we're going to be installing a Postgres database for our application to consume. And we're going to do that in the cloud. And then we're also going to do that on premises using Rook as well to get Postgres up and running. And so this will demonstrate that portability of our application just needs to know that it wants Postgres, and the control plane will figure out what Postgres to give you. All right, let me just make sure that it's running. Cool. All right, it's running. All right, so Crossplane is up and running, and let me just copy a whole bunch of stuff here to kick off the Google install, and then I'll explain what I did. Yeah, Google Cloud SQL database takes like, I don't know, minutes to spin up, so I wanted to kick it off so it's going right now. Okay, so let's talk about what I did. And let's start looking at it too, actually. Let's do that. That'll be more useful for you guys. Okay, so let's look at a workload. Okay, so on the left side of the screen, we have our workload that is going to run in the cloud. And on the right side of the screen, we have our workload that's going to run like on premises. And by workload here, that terminology gets thrown around a lot. And really what I mean by workload here is application. So the application on the left is going to run in the cloud. Application on the right is going to run on premises. And so what's interesting here is that they look the same. They specify that they're a workload, and they are going to run my app 1.0, and they need Postgres as well. both of these things are basically the same. Very similar. So, how do we go about doing that, right? So very similar to a persistent volume claim, what I'm showing you now is a Postgres claim, where on the left, our application that's going to go to the cloud says that, I need Postgres, and here's a storage class that defines the implementation of my Postgres. On the right, same thing. It's a Postgres claim, just like a persistent volume claim, and it has a storage class that defines the implementation, where that's going to come from. And so this is all the developer needs to know about. So as the administrator creates these resource classes. It's almost the same thing as a storage class that you get in upstream Kubernetes. So these are the two resource classes, and these do diverge. They're different because these are specifying the specific implementation of Postgres that we're going to use. So this one on the left is going to run Cloud SQL in Google and GCP, and the one on the right, its provisioner is going to be CockroachDB, because the CockroachDB implements the Postgres wire protocol. And so this is, the provisioner here of Cockroach and the provisioner of Google Cloud SQL, that's the exact same thing that we saw in the storage class earlier for Rook of saying use Ceph block storage. Same thing. Use Cockroach, use Cloud SQL. But importantly, our workloads don't change. Our application is the exact same in the cloud and locally. So let's load up the GCP console. And let me switch to my work account. I don't pay out of my own pocket for Cloud SQL instances. Cool. So we have, it looks like it's already done. So we have a Cloud SQL Postgres database that was dynamically provisioned by the Crossplane multi-cloud control plane, very similar to how volumes get dynamically provisioned inside of Kubernetes, like a EBS or Google Persistent Disk. So this portability now extends to new types. So we did that for Cloud SQL, and we'll look at some more details. But let's do the same thing for Cockroach. So what I first need to do is, in my on-premises Rook cluster, I am going to start up the Cockroach operator. Oops. There we go. So similar to the Ceph operator that we saw in the Rook demo, we have a Cockroach operator that's sitting there in a control loop, and it's waiting for the desired state to say, I want Cockroach. And then it'll make Cockroach happen. It'll deploy out a distributed Cockroach cluster. So the operator's running. And let's create our resource class, or our storage class. And let's create our claim as well. Remember that the claim was saying I need Postgres and to use this storage class here, and the storage class itself is specifying to use a provisioner of Cockroach. And so this is kicked off now, and so the Crossplane control plane sees that you want Postgres and you need Cockroach, so it's going to do that dance there, very similar to upstream Kubernetes doing the dynamic provisioning dance for talking to the right volume provisioner to make a volume happen. The right Postgres provisioner is going to make Postgres happen. And let's take a look-see at this. And what we should see here is a set of Cockroach pods running that would create the Cockroach cluster. Yep, so we've got 3 Cockroach nodes running now in our Cockroach cluster. And now we can take a look at the full status of all these guys. So we have 2 workloads. We're going to run running in the cloud, run one running locally. And so now we're going to use kube control to say, in this multi-cloud control plane, give me all the Postgres that you know about. And so that should be 2 Postgres. We have one cloud Postgres and one local Postgres. And we also see that they're both bound. Very similar to persistent volume claims and persistent volumes. When a claim is created that says, I want a volume, the volume is dynamically provisioned and they're bound together, the claim and the volume. Same thing here, that our Postgres claim is bound to, in the case of the local cluster, it's bound to an instance of Cockroach. In the case of the cloud Postgres claim, it's bound to an instance of Google Cloud SQL. So now with our application workloads here, and using some very familiar concepts of classes and claims, and having a control plane that spans across multiple clouds, multiple deployments, multiple environments, we can start thinking about how we can write our applications in one way, in a portable way, that can be deployed to anywhere in the world across all these different environments, and optimize with the smart scheduler for the particular properties that we want, cost or availability or compliance, etc. So this is starting to build this framework that enables us to write portable applications in the truest sense of the words. In Kubernetes, applications are portable if they're just containers and volumes. That's it. If you go outside of that with databases and message queues, et cetera, you lose that portability. You no longer have it. But Crossplane is a step towards enabling full application portability for your applications across all these environments. So those are a couple of other links and such to other architecture and presentations from the last KubeCon, et cetera. But so kind of wrapping it up here a little bit, is that both Rook and Crossplane, they're open source projects. They have their own communities. They've got Slack workspaces, Twitters, forums, community meetings every Tuesdays at 9 a.m. Pacific, which is 4 p.m. now here in UK time. But these community-driven efforts here, that's one of the things that I love the most about working in open source, is seeing communities start growing and building around these projects. So if you like to write code, or if you even want to use the software and write bugs or issues that you run into, feedback, chatting with us, we love that, because building communities and making sure that we're architecting and building something that people want to use is important. So I love being part of open source communities across the globe, and that's why I was talking to Justin, and I was just really happy to get a chance to come talk to people. And maybe you think these projects are cool, maybe you think they're stupid. But getting to know that feedback and have those conversations is so valuable, and it's something I absolutely love. So candid feedback and questions and discussions I love it. That's amazing. So thank you for listening about Rook and Crossplane tonight, guys. I appreciate it. Which slide? Oh, you want to take a picture? Oh yeah. Good call, Justin. Yeah. So so we can talk after this, have conversations, or if anyone has questions about Crossplane or what it does, or what's actually implemented now, because we've been coding it for like 4 months. So there's a big vision about picking the cheapest cloud on demand and all that. That's not implemented yet. That's the vision, but that is not coded yet. So we can full open transparent conversation. I'm happy to talk about anything, and I'm also still interested, if we have time, if Alex wants to talk about Storage OS, because I think that's pretty cool too. Okay, and there's beer. Yes?
I guess one question is, one of the criticisms, I suppose, seems to get about with the kind of multi-cloud approach, is that you're sacrificing the ability to use the kind of the things that make some of those services the best offering from the individual vendor services, whatever from Amazon is specific features of that service. How do you kind of tackle that with Crossplane? Because I guess with your abstraction, you're abstracting away some of those features.
Yeah, that's a very informed question again out of you, and I love that. You have great questions, man. I mean that's a common pattern that you see happen when you try to come up with an abstraction that gets away, clears away some of the details of the underlying implementations and comes up. You often end up with the lowest common denominator, where you lose some of the special uniqueness out of some of the underlying implementations, and so a lot of times that's hard to avoid. Some in certain circumstances, if you truly need certain features that are only available in certain distributions or certain services, then portability might not be what you're looking for. It might not be a good fit for you, and that's perfectly okay. The vast majority of situations here or scenarios here is going to be where you need a resource that implements a certain protocol like Postgres or S3 or whatever, and the abstraction works for you. And so that's really kind of what we're going after for scenarios where you don't need special features. But I was listening to a podcast with Tim Hawkin, who's big in the Kubernetes community. He's been at Google, I think, for God knows how many years. Brilliant man. And he was talking about the problems they had in that very situation where they were trying to model, I think it was ingress controllers, and load balancers, and all the different cloud load balancers, ELBs and Amazon and whatever the heck else they are in other clouds. There are specific features that are only available on certain ones, and how do you create an abstraction for load balancers and ingress that allows you to use those certain features? And Tim Hawkin was saying that they ended up with annotations that you can add an annotation to this object, and then that it gets all messy, and it was like a poor structure, and it was a mistake. And so the interviewer of the podcast was asking Tim, so what should you do then instead of those annotations? And Tim's like, well, we're thinking about that. And I was listening to that podcast like, here's my answer, here we go, I'm gonna find it out, damn it. So there's more to think about. If you don't want to just be lowest common denominator, what do you do? And I don't have a great answer for that, honestly. We have to think about that. Cool. Anyone else, or did we get Alex up here?
Other cloud providers in the works.
Yeah. So the ones that we support right now are Amazon, Azure, and Google, and then support for other ones coming down the pipeline that I don't know if we're committing to them specifically like a next milestone, but sometime in the future would definitely be Alibaba is a big one for me since they're enormous presence in Asia. And then DigitalOcean is one I like as well that has some cool services coming out that I think would be interesting to integrate with. And then what's probably going to happen though is that I see the project continuing to gain popularity and supporting more features, and then not focus on cloud providers, but then the cloud providers will come to us to integrate into the project. Like we've already gotten some people from inside Azure have asked to do some implementations of more resources, because it kind of becomes, if you look at it, it's kind of in the best interest of some of the cloud providers to say, on Crossplane, Azure's the best. It's better than the Google support, so use it for Azure. And it's a weird kind of dichotomy there, or competing priorities, but it ends up at the end of the day with more contributions to the project, broader scope of implementations and feature compatibilities and all that sort of stuff that I think is, that's probably what's going to happen, is that the community is going to build more support for other ones.
Do you ever see it being used for private clouds? So within an enterprise, if they have multiple sites across the globe, they could potentially use it internally to decide where to schedule stuff?
That's a good question. I don't know. I don't have a good answer for that, honestly. I haven't thought much about that. When I think of on-premises and private ones, the way I've been thinking about it is Kubernetes clusters running operator patterns like Rook and the cockroach demo I showed. That's kind of the way I've been thinking about it. And in terms of could you use the scheduler or other parts of the smarts of this control plane to do things internally and privately, I don't know. But that's an interesting idea, though. I hadn't thought of that.
Crossplane merging or coming together at some point?
No, I see them as being independent in terms of organization, repos, the releases. I think there's still very distinct independent projects that have independent charters, but I do see integration and strategy there of Crossplane taking advantage and usage of Rook for on-premises types of deployments, but not being merged into the same project now. All right. Cool. Well, flag me down later on if you want to talk more. I'm happy to talk. How late does the tube run around here, by the way, underground? Is it all night? Nice.